Okay, so in going over our KWL charts, we already talked about a triangle. Does anybody think that they can give you definitions? Good.
Three-sided figures.
Sure. That's a pretty good definition. I'm going to use some more math words, and I'm going to use the word polygon. So a triangle is a polygon with 3 sides. There are 2 ways that we're going to be able to classify these polygons. We are going to be able to classify them by sides, by how many congruent sides they have, and we're going to be able to classify them by their types of angles. All right, so that's what Kelly was saying in her "What do I want to know" section. She wanted to know all the different types of triangles. That's what we're going to talk about right now. So if we're talking about classifying our triangles by sides, we have 3 names we're going to talk about. The first one is the only one that you guys did not name already, and that is a scalene triangle. Scalene. And a scalene triangle is a triangle with no congruent sides. The second one that we're going to talk about that you guys did name when we were going over our "What did you know" column is an isosceles triangle. Now, since that's one you named in your "What do I know" column, can anybody tell me, raise your hand please, what an isosceles triangle is? You're close. So Kelly said 2 congruent sides. This one's actually really tricky because up until now, they do teach you 2 congruent sides, but there's actually some words we need to add in there. An isosceles triangle has at least 2 congruent sides. So an isosceles triangle can have more than 2 congruent sides, and it's still isosceles. And the last one, which is also one that you guys already named when we were having our little chat, is an equilateral triangle. Anybody tell me what an equilateral triangle, Diane? All sides congruent. All sides congruent. Or I'm going to write 3 congruent sides. So this is interesting. So an isosceles triangle has at least 2 congruent sides. What does at least mean? Felix?
It could be some isosceles triangles could be equilateral because there could be more than 2 congruent sides, which would be all 3 of them.
Right. Okay. So here's what he said. He said at least means 2 or more, right? So I could have an isosceles triangle with 2 congruent sides, or I could have an isosceles triangle with 3 congruent sides, and it's still isosceles. All right. Then we go to the angles. We're going to classify by angles. This one has a little bit more. We have 4 choices when we're classifying by angles. The first type is an acute triangle. An acute triangle has 3 acute angles. All 3 of the angles have to be acute. The second one is a right triangle. And a right triangle has one right angle. So it doesn't have to have all three of them be right angles. That would be silly. Just one of them needs to be a right angle. An obtuse triangle has one obtuse angle. And the last one is an equiangular. Which means three congruent angles. So equilateral meant three congruent sides. Equiangular means three congruent angles. Now, you can mix classification by side and classification by angle. For instance, I can have an obtuse isosceles triangle, or I can have a right isosceles triangle. Okay? I can have a right scalene triangle. But what I can't mix is I can't mix my classification by angles. Like I cannot have a right obtuse triangle. That's not going to happen. I cannot have an acute obtuse triangle or an acute right triangle. It has to be only one of these first three. Okay. Now, somebody did mention something that had to do with interior angles, so we're going to talk about interior angles. Interior angles are just the angles inside the triangle. Angles inside the triangle. An exterior angle is an angle that forms a linear pair with an interior angle of the triangle. So, angle A, angle B, and angle BCA are all interior angles of my triangle. So I'll write that up here. Examples. Angle A, angle B, and angle BCA. They're all interior angles. Then we have this angle 1. Angle 1 is an exterior angle. For every interior angle, you have an exterior angle. So what interior angle goes with the exterior angle, angle 1? No, it has to form a linear pair. Does angle 1 form a linear pair with angle B? What does angle 1 form a linear pair with? Which interior?
Angle C.
Guys, how many angles are there at angle C? No, there's multiple angles at angle C. You cannot just call it angle C. That's not okay. Angle 1 has a vertex at angle C. So I need to know what you're talking about. So angle 1 makes a linear pair with which interior angle? I just named all three for you. Which one has C as its vertex? Angle A, angle B, or angle BCA?
Oh, angle BCA.
Thank you. Angle BCA. That is what makes a linear pair with angle 1. That's the angle it's attached to. Now, if I would like to make an exterior angle for angle B, I would just extend where it is at angle B. I could call it angle 2. That would be the exterior angle. And then if I want to make an exterior angle for angle A, I can extend that side to make a linear pair. I could call that angle 3. So how many exterior angles does any one triangle have? How many exterior angles does any one triangle have? Raise your hand if you think you know. Teddy?
I'm not sure. Maybe
No? There's a number. Isaiah?
6?
How'd you get 6? I only see 3 here.
Because there's like 4 possibilities.
You can go clockwise, right? So that's angle 3, 2, and 1. Or I can draw my exterior angles the other direction, right? So what if I drew an exterior angle this way for angle B and this way for angle A? So there are 6. So if you have room, write that down. Every triangle has 6 exterior angles. Now, clearly, we do not draw them all at the same time, because if we did, we'd get this like funky looking shape and we wouldn't know which angles are our exterior angles. So we only draw 3 at a time, but there are actually 6 exterior angles. All right, on to the theorems that you guys are telling me you already know. So the first theorem is called the triangle sum theorem. And the triangle sum theorem says the sum of the measures of the interior angles of a triangle is 180 degrees. The sum of the measures of the interior angles of a triangle is 180 degrees. Loki shared that with us when we were talking about what you know. That was something she said she knew. So we have an interior angles theorem. We also have an exterior angles theorem. The exterior angles theorem is a bit lengthier, so make your words maybe a little bit smaller. But it says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. What does adjacent mean? Or non-adjacent? Either one. Tell me what either of them mean.
To be directly across from.
Which one are you doing? Adjacent? Adjacent means directly across from. I don't want to use that word across. I don't like that word. They're not necessarily across. If they are adjacent, they are going to share a side. Adjacent angles share a side. Anything else we know about adjacent? Say it. They do not overlap. Good job, girl. That's a big thing. We like to say, when I use the word adjacent, I like to say that they're next to each other. That's what adjacent means. They're next to each other. They share a side. They're right next to each other. All right. So what's really important here is to take note that we're talking about the non-adjacent. So anything that's not next to angle 1. So the measure of angle 1, our exterior angle, is equal to the sum of the non-adjacent interior angles. So which angles inside the triangle are not next to angle 1? Angle A is not next to angle 1, so we're going to write that one down. What other one's not next to angle 1? We're talking about interior angles, so you only have 3. Interior angle, interior angle, interior angle. Which one is not next to angle 1? Is that?
Angle B.
And angle B. So the measure of an exterior angle, you're going to add up the 2 non-adjacent interior angles. So the ones that are not attached are the ones that you're going to add. So let me just give you a little example here. So if I know that this is 45 degrees, and I know that angle B is 30 degrees. What's angle 1 have to be? 75 degrees, right? Angle 1 have to be 75 degrees. Which we could also figure out using the triangle sum theorem. Because if you use the triangle sum theorem, you're going to get 45 plus 30 plus whatever this is has to add to 180. So what's that? Let's figure that out. 45 plus 30 plus the measure of angle C has to be 180. So what's the measure of angle C have to be? 105? And since these guys make a linear pair, you get 75. So there's several ways that you can kind of show that this exterior angles theorem makes sense. But the exterior angles theorem says the measure of an exterior angle equals the sum of the non-adjacent. So you're going to add up the ones that aren't next to it. Yes, Cal?
So the angle B is 30 degrees, angle A is 45 degrees. How does angle C?
Because we just learned the triangle sum theorem. This picture is not necessarily drum scale. I mean, I just freaking did it. The triangle sum theorem says that all the angles inside add to 180. So if these are 75, then that has to be 105. It's not drum scale. I just sketched it and then I just picked numbers just to kind of show you, just to give you an example. We'll do some problems, you'll see. Then we have a corollary. A corollary is actually a mini theorem. That's what you'll hear Miss B call it most of the time. It's a mini theorem that can easily be proven, can easily be proven, using the theorem it is named after. So a corollary is like a mini theorem, and you prove it using whatever theorem it's named after. So if you look at the next box, it says corollary to the triangle sum theorem. All your corollaries will be like that. It will say corollary to, and then name a theorem that we've already learned. Because it's kind of like an addition to that theorem. It's like a mini theorem, a subset. So the corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. Which makes sense because in a triangle, the triangle sum theorem tells us that these three angles have to add to 180, right? All three of these. Well, if this guy takes up 90 of that, then what's left for A and B? 90. 180 minus 90, there's only 90 left. So whenever you have a right triangle, you know the other two angles are going to add to 90. Those other two angles have to be complementary. Alright, so let's do some examples now. So we learned a good bit of theorems here. We learned the triangle sum theorem, we learned the exterior angles theorem, the corollary to the triangle sum theorem, we learned 7 ways to classify triangles. So let's put some of this into practice. So example number 1 says, complete each statement with the words always, sometimes, or never. Here's what I would like you to do. I'm going to set my timer. I'm going to give you 2 minutes. That's it, 2 minutes. See if you can figure them out on your own. Always, sometimes, or never. 2 minutes, and then we're going to do them together. Oh no, where did my little recorder go? Am I still recording? Yep, still recording. Okay, so let's see what you got. If a triangle is isosceles, then it is always, sometimes, or never equilateral. If a triangle is isosceles, always, sometimes, or never equilateral. Sometimes. When? I was going to say when is it equilateral, but it's equilateral when it has 3 sides instead of just 2 congruent. Because remember that definition of isosceles is that 2 or more. So if you have 3 sides congruent, you're still isosceles. Can we put our heads up, guys? Sit up. Wake up. Letter B, if a triangle is equilateral, then it is always, sometimes, or never isosceles. Is it? The triangle is equilateral. Good job. I thought those two were the toughest too. Then it is always isosceles. How many people got both of those? Raise your hand. It's good. Letter C. If a triangle is scalene, then it is always, sometimes, or never isosceles. Eduardo. If a triangle is scalene. Never. If a triangle is scalene, then that means no congruent sides. So it can never be isosceles. Letter D. If a triangle is obtuse, then it is always, sometimes, or never isosceles. Jennifer, what do you think? If a triangle is obtuse, always, sometimes, or never isosceles? Never? I can draw you an obtuse isosceles triangle. Sometimes. It's going to be sometimes. Because there are triangles that are isosceles and obtuse, and there are triangles that are obtuse and not necessarily isosceles. So sometimes our obtuse triangles are isosceles, sometimes they're not. If a triangle has two complementary angles, then it is always, sometimes, or never a right triangle. Notion. Yeah, if you have two complementary angles, then it's definitely a right triangle. That was our corollary that we learned. And the last one, a corollary to a theorem is always, sometimes, or never an acceptable reason in a proof. Are we going to be allowed to use these corollaries when we're doing our proofs? Yes, always. Always. You may use your corollaries in your proofs. So now, when we're doing our proofs, we have definitions, postulates, properties, theorems, and corollaries. You can use all of them. Alright, so let's do some problems. So example 2 says just find the value of x. And in both of these pictures, x is one of our exterior angles. So we need to think about that exterior angle theorem. So let me highlight my x for you, my 3x, my exterior angle here. Now, the exterior angle theorem says that the exterior angle is equal to the sum of the non-adjacent interior angles. Which two angles are non-adjacent to 3x? Isaiah? Yep. This guy and this guy. So we can set up an equation, the sum. What does sum tell us that we're going to do? Add. So the sum of the two non-adjacents is equal to our exterior angle. Then we can solve, so we get 80 is equal to 2x. So x is 40. Do I need a degree symbol next to my 40? Why? Yes, because... No? No? Why do I need a degrees? You're correct. Tell me why.
Because it's the measuring.
It's the measure of this angle. It's the measure of angle S. The measure of angle S is 40 degrees, so we need that degrees. Letter B is a little bit trickier. Trickster, trickster. Let me highlight for you. Allow me. I'm highlighting for you. Which which two angles are my non-adjacent interior angles? Which two angles are my non-adjacent interior angles? Now I know this doesn't have letters, just tell me by measure if you can. Say it. Measure 25 degrees, that's going to be one. And what's the other one? Is 150 an interior angle though? No, 150 is not an interior angle. So what do we have to do, Isaiah?
You have to, like, do something.
First, we have to find that interior angle. 150 is not our interior angle. This guy right here is the interior angle, and we're missing him. So first, we have to use our linear pair to find our interior angle. What do we know about a linear pair? They add 180. So 150 plus, I don't know, what do you want to call it? Let's call it J. Sure. Equals 180. So that means I should say the measure of angle J is 30 degrees. So that guy's 30 degrees. Now I can find X, my exterior angle, by adding up what two numbers? Count. 25 plus 30, so X is 55 degrees. So that was a two-stepper. Just had to do an extra step. Example 3. So in example 3, we're using some parallel lines. So we're going back to unit 3. We're incorporating some of our parallel line rules that we learned. So I'm going to start out by highlighting my parallel lines. That sounds good, right? Parallel line, parallel line. And which transversal would you guys like to use first? The one that's going up or the one that's going down? Yeah, I agree with you. I would say the one that's going up, because when you use the one that's going up, your X is completely highlighted. It's completely covered. So it should be very easy to find the measure of angle X because it's completely highlighted by our parallel lines and our transversal. What's the measure of angle X? And how do you know? You shouldn't have to do any algebra to figure it out. Notion? 30 horses? 30 degrees. Oh, sorry. I wasn't sure. And how do you know? What type of angles are X and 30 degrees? They are alternate interior angles. Remember, they make the Z. That's from Unit 3. You just took that test last class. I'll write that down so that you remember when you do your homework. Okay, so that helps us because what type of angle is angle Y? Might be a little hard to see. Notion? No? It's not one of our parallel line types. Y, if you look at Y, it is not completely covered by highlighting. So that means it's not one of our special types because of our parallel lines. So we need to look at something else. Like, I don't know, maybe let's look at our triangles. I'll highlight, let's highlight this triangle over here. How is Y related to that green triangle? It's an exterior angle. Good job. It's an exterior angle. So Y should be equal to the sum of what two angles? Yep. 45 plus 30. which gives you that y is 75 degrees. No, no horses, just degrees.
You must be in a magical way.
Perhaps.
And so the angles of some.
In letter B, I highlighted my parallel lines. You can use them if you would like. But to be honest with you, I probably wouldn't use my parallel lines first. I think there's an easier way to find one of these angle measures. So you guys think about it a second. Go ahead, Ash.
This would be equal, like, measure for 80 for x, which would be
No, x is not outside. X is an interior angle. What is the sum of interior angles? 180. The sum of my interior angles is 180. So what I'm going to do is I'm going to do 90 plus 50 plus x has to equal 180. Good. So Felix said that x equals 40 degrees. Yep. That's good. So now we have x. We used this triangle down here. We did the triangle sum theorem. We added them all up to get 180. Now maybe I can use my parallel lines. So I got this parallel line, this parallel line. Which transversal would you like to use? The top one, the diagonal one? Let's use the diagonal one. What do you notice? What letter did I make with the blue? A Z, so what type of angles do we have here? Ashley. Congruent angles, but how do you know they're congruent? Because they're what type? They're alternate interior, and which ones are you thinking are alternate interior?
x and one.
Yeah, the X, and this guy down here. So that means this guy down here also has to be 40 degrees. And then what are we going to use again to find y? Louder? I didn't hear you. Plus x. No, we found x. 40 plus 100 plus y equals what? 180. And what's that called again? The triangle sum theorem. So 40 plus 100 plus y equals 180 because of this top triangle. So that means that y is also 40 degrees. This next one's my favorite. So this next one, we just have one big triangle, and then we have a whole bunch of little triangles inside. So this is our triangle sum theorem problem, right? So we're going to find all of our angles using this triangle sum theorem. Anybody got any ideas? Anybody got a triangle that you want to use first that can help us to find an angle? Go ahead, Isaiah.
The bottom right.
The one with the 20 degrees and the 90?
Yeah.
Okay, so let me highlight that for you. So Isaiah's going to use that one. So then what's our missing angle in that bottom triangle?
70.
Has to be 70 degrees. 90, 20, 70. That's what adds to 180. So if this angle is 70, what other angle is 70 degrees? Can you please go ahead?
Vertical.
They're called vertical, right? Use your math terms, your math words. So that means that this angle up here is 70. Good. Now I can use that top triangle to help me find x. What are we talking about raising our hands? So x plus 25 plus 70 has to equal 180. So x plus 95 has to equal 180, and Felix already said that that means that x is 85 degrees. Still got one to find though. We still have to find our y. Y is actually easier than x. As long as you see it. It's kind of hard to see this triangle. Anybody that sees a triangle that has y in it that can help us find what y is? Huh? 25. Say it again. That's not going to help us find y though. Y is down here. Babette? You mean this triangle? That's not gonna, I mean, that could help us find y, but you're gonna have to do a lot of work. There's a triangle that we can find y right away without doing any other work. Ash?
It goes from half and half, right?
Yeah, it's the tall half, right?
Yeah.
That guy. That guy's gonna help us find y. So y plus 25 plus 90. This is 90 right here on both sides equals our 180. So what do you get for y? Raise your hand.
Be lower than
65 degrees. Woo! Yay! It's so fun. So let's highlight our parallel lines. Which transversal would you like to use? The one going up. I concur. So this is a very clear Z, right? So that means we have alternate interior angles. Can anybody tell me which ones are our congruent alternate interior angles? Kelly. Yeah, so what do I do with alternate interior angles? I can't hear any of you. You're all mumbling. Raise your hand. Notion. You said them equal, right? They're congruent. So we have negative 4x squared plus 26x equals 30x minus 24. Now we have an x squared. Luckily, We did a factoring unit, so we all know how to solve when we have an x squared. What's our first step? Raise your hands. What's your first step?
Oh.
7. Even before that. Jennifer? Get 0 on one side. So I'm gonna minus 30x on both sides. And I'm gonna add 24. I'm doing it all in one step because we're in geometry now, not algebra 1. We should be able to move things in unison. Which leaves us with this. Then Bevan's like, Miss B, you better find a GCF. Bevan, what's my GCF? You're so close. Negative. There's a negative out front. When there's a negative out front, it's part of your GCF. So I am going to bring my negative 4 out front and divide everything by negative 4. So then what do I have left after I divide by negative 4? Eduardo, what do I have left? X squared plus x minus 6. And whenever you have a GCF, what do you got to do with it? Bring it down. Thank you, Miss Camilla. Bring it down, open up parentheses, and set it equal to 0. You got to bring that equals 0 down. Then I can forget about him. It's like he's not even there. I took him home. You took your little brother or sister home, so now you can pretend that they're not around. Do you guys want to do the short method or the long method? I would like to do the short method too, so I'm actually going to raise that up a little bit so I have some room. What do I get that multiplies to negative 6 and adds to 1? Count. That doesn't matter. So if I do 1 and negative 6 or negative 1 and 6, that's negative 5 and 5. Yeah. And then I have 2 and negative 3 or negative 2 and 3. Which one do you want to pick? Ash? Yes, negative 2 and 3. So that goes right in the parentheses, x minus 2, x plus 3. And then what's our very last step? Set everything equal to 0. Negative 4 equals 0, x minus 2 equals 0, x plus 3 equals 0. Does negative 4 equals 0 make any sense? No, cross that out right off the bat. So then we get x is 2 and x is negative 3. Now, up until now, everything that Miss B has given you when you've gotten a quadratic, both of your answers have always worked. That's not always going to be the case. Sometimes they do not both work. This is our first example of when that happens. Which one of these, when you plug in for x, is going to give you something that does not work, that does not make any sense? Negative 3. Good job, Jennifer. If I plug my negative 3 in up here, I get 30 times negative 3 minus 24. I get that this angle is negative 114 degrees. Does that make sense? Can I have an angle in a triangle that's negative? No. So I had to cross that puppy out. That guy does not make sense. Okay? Sometimes you will get answers that don't work for our situation. You need to make sure that you're crossing those answers out. So from here on out, you need to be plugging them back in and checking to make sure are we getting a positive angle measure? Because we're not allowed to have negative angles. All right. Now, if I plug 2 in, 2 works. We get 60 minus 24, so that's 36 degrees. And if I plug 2 in down here, I get negative 16 plus 52, which is also 36 degrees. All right, so there's my guy. So now I know X. Huh? Now I know X, yep. Now I just gotta find Y. Y is the easy one. How am I gonna find Y? Felix?
You had 100 plus 36.
Yep. I got this triangle here. I'm gonna use the triangle sum theorem.
Yeah.
Oh, it's kind of hard to see down there. Do it up here. 100 plus 36 plus y is 180. So 136 plus y is 180. So what's y going to be? Is she right? Felix, don't tell yourself.
It's 44?
Thank you.
Yes.
It is not 54
Yes.
degrees. It is 44 degrees.
Yeah, I'm like giving myself all my life.
It is 44 degrees. Woo! That one was a hard one. I love it. Isn't it so fun to use quadratics and triangles?
No, but I like being right.
Alright, last thing we're gonna do today. Another super fun thing.
No!
Proofs! Spirit fingers for proofs. Okay, so we are going to prove the exterior angle theorem. Last thing we're gonna do today. Prove the exterior angle theorem. Sorry, I'm getting scared that I'm gonna have to record again, but my thing's still there. Okay, so when we are proving, remember what we talked about. Your given is always your if, or whatever we're starting with, and our prove is always our then, or what we're ending with. Okay? If I'm proving the exterior angles theorem, what do I need to have in order to even be talking about exterior angles? What do I have to have? What are we just starting to learn about? Huh? Triangles. So my given is just that I have a triangle. I have triangle ABC. That's my given. That's what I'm starting with. That's what I need to have in order to be able to have an exterior angle. What I want to prove, what the exterior angles theorem says, is that the measure of an exterior angle is equal to the sum of the non-adjacent interior angles. So really what I'm trying to prove is that the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. That's what the exterior angles theorem says. That's what we've been using it for, correct? So always start with your given. Always, always. What does your given tell you? If I say ABC is a triangle, what can you tell me about ABC? There is something you can tell me. We learned it today. What did we learn about triangles today that you can tell me? What did we learn? What? You both were talking at the same time. I did not hear you. You said a triangle. What does that tell you? We already said that. Triangle ABC. We have triangle ABC. Knowing that ABC is a triangle, what did we just learn about all triangles? Isaiah?
The angle itself is up to 180.
Thank you. One of the most important things we learned today, the sum of the interior angles is 180 degrees. So I can add up angle 2, angle 3, and angle 4, and I should get 180 degrees. That's what we learned today. What is my reasoning? What did we call them? Kel? That's the triangle sum theorem. Okay. Now, we got 3 and 4 mixed in there. We need to figure out a way to get angle 1. Is there anything that you can look at this picture and you know about angle 1, that you can somehow involve angle 1? What do you know about angle 1? Anything? Teddy? You don't know that. I didn't tell you any measures. You do not know that it's a cube. Evan? Yeah, it's a linear pair with angle 2. So what do you know about linear pairs? They add to 180. So for step 3, I can say the measure of angle 1 plus the measure of angle 2 equals 180. And who remembers the reason I gave you in Unit 3, we talked about this, that when you have a linear pair, they add to 180. It is a linear pair. You got it?
Yeah, she said.
The linear pair postulate. Okay, so we just pulled from the diagram. Remember, after you pull from the diagram, you gotta go back and look at what you have and see if you can get to your next step with what you have. Don't just keep pulling from the diagram, or you're gonna have all these different statements that don't go together. We have to go back, look at how our statements relate, and see if we can make another statement.
The number 1 on
All right. So what do you think? Evan? No, you cannot. You cannot just cross out the measure of angle 2. No, shit. No, because we don't have one equation. When you subtract, it has to be on both sides of the same equation. If you can write me an equation, anybody want to do that? Loki? No, that's what Febin said. It does not cancel out. Felix?
Did you do like transversal? Like, substitute angle.
You mean the transitive property? Yeah. It depends. What are you saying that my middleman is?
Your middleman is the measure of angle 2.
No, it is not.
Oh, 180.
Felix?
Your middleman is the 180.
Your middleman is 180. You guys keep doing this. You cannot just take out one part. You have to take out the entire side. So if I'm canceling out a middleman, he has to be the entire side of the equal sign. So then I have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. That is because of the transitive property, not the transversal. Transitive property of equality. And now, what can we do, Notion? Now I can minus the measure of angle 2 because it is on both sides of my equal sign. So I'm left with the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. And what's my reasoning, Notion? Subtraction, property of equality. How, did I use a congruency symbol?